For most of human history, growing food meant starting over every year. Fields were cleared, seeds were planted, soil was disturbed, labor was repeated, season after season, because we assumed that was the only way agriculture could work. But for centuries, entire communities relied on a food source that broke that rule completely. It didn't need to be replanted every year. It didn't demand constant soil disturbance. And once established, it kept producing food with far less effort than annual crops ever required. This wasn't experimental farming. It was a system people depended on for survival. One that made the endless cycle of annual planting look unnecessary, even inefficient. Somehow, we moved away from it. Not because it failed, but because our food systems began valuing speed, uniform harvests, and short-term output over continuity and resilience. Understanding why this perennial food was sidelined forces us to question assumptions we still live with today about work, efficiency, and what progress in agriculture really means. Before we continue, kindly tap the subscribe button on your screen to uncover more forgotten food systems on the Lost Food Archive. This story isn't about going backward, it's about noticing what modern systems stopped seeing. Today, agriculture is built almost entirely around annual crops, plants that must be replanted from scratch every single year. That design choice shapes everything: constant labor cycles, repeated soil disturbance, heavy dependence on fertilizers, irrigation, and timing precision. Productivity is achieved, but only through continuous intervention. Perennial food systems offered a fundamentally different logic. Instead of restarting each season, they invested once and harvested repeatedly. Instead of managing collapse and renewal every year, they prioritized continuity. These systems didn't chase maximum short-term output, they optimized for stability over time. Understanding this food reveals a blind spot in modern agriculture, not a missing technology, but a missing design philosophy, one that treated longevity, reduced labor, and ecological balance as primary goals rather than side benefits. A perennial food plant is one that regrows year after year from the same root system. It doesn't require annual replanting. Once established, it returns on its own schedule. Its roots grow deep, accessing water and nutrients far below the surface. That depth stabilizes soil, reduces erosion, and buffers the plant against drought and variability. Yields may not spike dramatically in a single season, but they remain consistent across many years. In contrast, annual crops live fast and end completely. They rely on shallow roots, frequent soil because the tree was alive. Communities depended on breadfruit at every level. Families relied on it for daily meals. Villages coordinated harvests and preservation methods. Chiefs and leaders used breadfruit groves as indicators of long-term stability. In some cultures, planting breadfruit was a social obligation, an investment made not for yourself, but for those who would come after you. This was not an experimental crop or an emergency fallback. Breadfruit was engineered into culture. Varieties were selectively bred for taste, yield timing, and storage potential. Surplus fruit was fermented, dried, or buried to enses lighter, not heavier, where stability compounds instead of resetting. But this wasn't theoretical. It worked, at scale, for centuries. The question this raises isn't whether breadfruit can replace modern crops. It's why systems like this were excluded from modern agricultural priorities altogether. What assumptions had to change for a food that feeds people? This perennial food was not marginal. It was not rare. And it was not a backup. Breadfruit fed civilizations. Breadfruit was cultivated across the Pacific Islands, Melanesia, Micronesia, Polynesia, and later spread to parts of Southeast Asia, the Caribbean, and East Africa. In these regions, it was not grown as a supplement to agriculture, it was agriculture. Entire food systems were structured around it. A single breadfruit tree can live for decades, often 50 years or more. Once established, it produces food every year without replanting. Mature trees can yield hundreds of fruits annually, each dense with carbohydrates, fiber, and calories. In practical terms, this meant that one planting decision could feed a household for a generation. There was no annual sowing season, no repeated soil clearing, no constant reset. Food arrived because the tree was alive. Communities depended on breadfruit at every level. Families relied on it for daily meals. Villages coordinated harvests and preservation methods. Chiefs and leaders used breadfruit groves as indicators of long-term stability. In some cultures, planting breadfruit was a social obligation, an investment made not for yourself, but for those who would come after you. This was not an experimental crop or an emergency fallback. Breadfruit was engineered into culture. Varieties were selectively bred for taste, yield timing, and storage potential. Surplus fruit was fermented, dried, or buried to create long-lasting reserves. Food security was not achieved through scale or speed, but through continuity. The mental shift here is important. Breadfruit didn't produce value by maximizing output in a single season. It produced value by removing failure points. No replanting meant fewer chances for disruption. Deep roots meant resilience against drought. Longevity meant predictable food without constant labor input. From a modern perspective, this can feel almost unreal. A food system where planting once replaces decades of repetitive work, where maintenance is lighter, not heavier, where stability compounds instead of resetting. But this wasn't theoretical. It worked, at scale, for centuries. The question this raises isn't whether breadfruit can replace modern crops. It's why systems like this were excluded from modern agricultural priorities altogether. What assumptions had to change for a food that feeds people for generations to be labeled inefficient? If you were designing a food system today, one meant to last, not just perform, would you choose annual control or perennial continuity? Share your thoughts in the comments. From the perspective of the societies that depended on perennial foods, annual farming was not innovative. It was inefficient in the long run. Annual systems required the same cycle every year, clearing land, disturbing soil, planting seed, protecting young crops, and hoping conditions cooperated. Each season, reset risk. Drought, pests, conflict, or labor shortages could erase months of effort. Food security depended on everything going right, repeatedly. Perennial systems eliminated much of that exposure. There was no yearly tilling. The soil remained covered year-round, protected by leaf litter and root networks that prevented erosion and retained moisture. Nutrients cycled naturally, instead of being constantly depleted and replaced. Over time, soil fertility improved rather than declined. Labor demands followed a different curve. Establishment required planning and patience, but once mature, the system demanded far less work per calorie produced. Food did not depend on peak labor availability every season. It arrived because the system itself was alive and stable. This mattered most during disruption. When storms destroyed fields, perennial trees often survived. When labor was diverted by conflict, illness, or migration, food production continued. When annual harvests failed, perennial systems acted as buffers rather than liabilities. The key insight is this: efficiency was not measured in speed or yield per season. Efficiency was measured in continuity across time. Annual farming maximized short-term output. Perennial systems minimized long-term risk. That difference reframes what advanced actually means. Perennial food systems were not passive or accidental. They were deliberately designed around long timelines. Planning began before planting. Land was selected not for immediate return, but for suitability over decades. Trees were spaced to allow sunlight, airflow, and understory growth. Companion plants filled gaps, creating layered systems rather than single crop fields. Stewardship was multi-generational. People who planted knew they might not be the primary beneficiaries. This changed decision-making. Choices favored durability over speed, resilience over extraction. Harvesting did not destroy the system. Fruit, nuts, or starches were taken while the plant remained intact. Roots stayed in place. Canopies regenerated. Production resumed without restarting the cycle. Regrowth did not require replanting. Energy stored in deep root systems fueled recovery after harvest, storms, or dry seasons. This internal reserve replaced external inputs. The system carried its own insurance. Nothing here was automated, yet nothing was fragile. The logic was embedded in biology rather than machinery. Where modern systems rely on intervention, these relied on alignment with growth cycles, climate patterns, and ecological limits. What made these systems powerful was not technology, but restraint. They avoided pushing beyond regeneration capacity. As a result, they endured. If agriculture today were designed for a 100-year horizon instead of a single season, what would change first? Let me know in the comments. Perennial foods didn't vanish because they were ineffective. They disappeared because the systems around them changed, and the new rules didn't favor them. Colonial powers prioritized crops that could be transported easily, taxed reliably, and harvested on a predictable schedule. Staple grains like wheat, rice, and maize fit that mold. Perennial trees or root crops, which produced over years rather than seasons, were inconvenient for these objectives. Later, industrial agriculture demanded uniformity. Machines, fertilizers, and irrigation systems were optimized for fields that could be reset annually. Anything that grew on its own timetable or required stewardship beyond a single season was incompatible with scale. Perennials didn't fail biologically. They failed to meet the logistical and economic priorities of expanding empires and industrial systems. Abandoning perennials came at a cost. Soil that once stayed covered year-round began to erode. Nutrient cycles required constant human input. Fields became fragile, dependent on energy, water, and fertilizer to maintain output. Labor intensified. Instead of steady, predictable work aligned with natural cycles, farmers now faced repeated, seasonal peaks. Risk shifted from nature to human management. Droughts, pests, or mechanical failure could halt production entirely. By prioritizing uniformity and short-term output, modern agriculture traded continuity for control and resilience for speed. What was gained in efficiency was offset by vulnerability, making the systems highly productive yet structurally fragile under environmental stress. Perennial crops are not relics. They are being actively studied and reintroduced. Agricultural scientists and ecologists are revisiting plants like breadfruit, enset, and perennial grains to explore traits that modern farming largely overlooked. Deep roots that stabilize soil, natural resilience to drought, and multi-year yields that reduce labor and input costs. Agroforestry and permaculture movements are experimenting with layered systems that combine perennials with annual crops, creating landscapes that mimic natural ecosystems while producing reliable food. In certain regions, from the Pacific Islands to parts of Africa, these crops remain staples, proving that the concept never failed. It was simply deprioritized in global food systems that favored speed, transportability, and standardization. Climate change adds urgency. Perennial systems offer resilience under unpredictable rainfall and soil degradation, requiring less energy-intensive management than conventional annual monocultures. Their survival and revival show that sustainable, long-term food security can benefit from lessons that were sidelined, not lost. Perennial crops like breadfruit are just one example of how human societies once designed food systems for longevity, stability, and resilience. Across the world, other forgotten foods and agricultural practices followed similar paths, thriving for centuries before being sidelined by industrial, annual-focused farming. Some relied on unique plant traits, others depended on carefully maintained social systems and multi-generational stewardship. Each tells a story not just about the food itself, but about the values and priorities that shaped entire civilizations. In the next episode, we'll explore another overlooked crop that was once central to survival, but vanished as food systems shifted toward short-term efficiency. Its story reveals a different type of ingenuity, showing how human choices, rather than biological limits, determine which foods endure and which are forgotten. If you want to continue this investigation into the infrastructure, plants, and practices that sustained societies quietly yet effectively, subscribe to the Lost Food Archive. Each episode uncovers a system that shaped human survival and still has lessons for how we grow, manage, and think about food today. Don't miss the next chapter in the story of forgotten resilience.